Welcome to the dynamic learning hub of XLR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. A hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. XLR. We don't just train, we build careers.
Yes, so the collaboration with XLR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in very detailed manner on how to give great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and it was a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if XLR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and took me to a great extent.
The experience of the workshop was really nice. The feedback from all the students was positive. They understood the concept. The workshop was also practical based with some questions. The experience with XLR was very smooth. They helped us in conducting the workshop smoothly right from the booking of the vendor and deciding the course till the distribution of certificates. In overall, this workshop was a success during our Technical Fest Atmos, and I thank XLR for being a part of it.
Good afternoon, every dear faculty members. So, hope all are doing good. Let's start the session. Today we have our trainer Sashank. So, Shashank, you can take up the class.
Sure, Chandan. Thank you so much. Is my voice audible, Chandan? It's fine.
Yes, yes, yes. Perfect.
Okay, thank you so much. Okay, so we'll continue from where we left off yesterday. We shall. Okay. So yesterday we were discussing about the self-driving cars. We'll continue from there, right? Um, so is my PPT visible, Chandana? Is it fine?
Yeah,
Okay.
please.
Okay. Fine. So we were actually discussing about the self-driving cars yesterday, where we understood that how things work. And first of all, we had some understanding of what is artificial intelligence and how things work in AI. So before going into the practical part and explanation, so there are some of some more concepts which we have to understand also. So, let us see some of the applications of what is AI. So, in what fields actually we are implementing this artificial intelligence and all. So, here I've mentioned some of the fields like gaming, social networking, computer vision, machine translation, healthcare. So, in this, what I've mentioned in this six, we are actually discussing about healthcare also, and many more are there, like even the finance sector, banking sector, what we are actually going to discuss as well. So computer vision, natural language processing comes under the machine translations. So there are many areas where we are implementing the artificial intelligence in the real time. So this is one important field where we are using the computer vision. The best example is the facial recognition. So, for example, you can see the facial recognition. Even when you see, particularly in the metro cities, you can see the images. The recognition will be done at the traffic signals also. So where they will be able to recognize your facial image and they can match also. So even you would have seen this also in movies. So this will be this example will make you to remember easily. So in movies also, you see in investigation movies and all, people try to match the images and all, right? So to find whether that person is matching or not. So this is a very good example of what you can see. What happens in the real time. So just for showing for making that movie, they show like that, but it is very similar to what happens in the reality as well. So these facial recognitions are matched basing on the features or basis of the features. So next thing is the augmented reality as well. So augmented reality, you can see that in the gaming, not just gaming also. So you have 3D, 4D, 5D, and all, and you can experience the reality of what is actually it feels or it makes you to feel that you are very near to that particular field and to experience that particular aspect. So that is one of the main advantages of using computer vision. And computer vision has actually brought a lot of advancements in the field of AI. And the technology what is actually used in computer vision is deep learning. So deep learning is nothing but we'll see a little more detail on what is exactly deep learning in the coming few minutes. So next thing is the machine translation. So machine translation is nothing but the voice to text or text to voice. So anything you can consider. So for example, if you ask Google, right? If you either you ask Google by typing a text, or you ask Google by actually using the voice, because there is also something called as a voice assistant also. So this is a very good example of how AI is actually working in the real time. So for example, like the voice assistants like Alexa, right? Google Assistant, and yesterday I was mentioning about the Google's advanced assistant called Gemini. So Gemini 1.0, and now we are in Gemini 2.0 as well. So there are a lot of advancements happening in the field of AI, and these are some of the examples of how things are working in the real time. So by using voice and text. So I think everybody, at least in once in your lifetime, maybe you would have used this machine translation as well. So for example, like from one language to the other language, you can translate. For example, you can see here because if you go to a certain place, for example, it need not be other country also. It might be other state also. For example, from one state to the other, if you are going and you don't know the language, you can use the auto translate feature where you can translate. So it uses that machine translation deep learning feature in the AI technology. And the most and commonly used feature is the autocomplete feature. So autocomplete feature, in Gmail you would have seen. So it's not just Gmail, even in Google search you can see the autocomplete feature. For example, if you type something in Google, it tries to suggest some of the things for you to type, right? So these suggestions are something which is one key thing I just wanted to tell. So there are two things when it comes to deep learning. One is using two important aspects. One is the computer vision and the NLP. So computer vision is nothing but which is completely related to images. So training the algorithm, building a model based on images is what a computer vision is. And using text and building a model is basically NLP, which is natural language processing. So when you are why I have actually picked this up is basically when you talk about the autocomplete feature. So the autocomplete feature, maybe it is either it is Gmail or any other place, or a Google search or any other place. The autocomplete feature actually uses the NLP technology, where it uses the algorithms basically for a layman to understand simple terms, right? Some might be having some experience with this, some might not have. So in a very very simple terms, to make you understand that what is machine translation is basically this autocomplete feature works on the basis of probability. So you would have been knowing probability concept at least, right? So in statistics we have the concept of probability. So the words which are trained takes the probability, or I can say it uses the concept of probability, which word has more chance of occurring in that particular context. That is what how we train the algorithm, train the model, right, by applying the algorithm. So how in that particular scenario, in that particular situation, or in that particular event, what you are actually typing, what word will have more chance, or when I say more chance, right? So chance is nothing but the probability. More chance of occurring, right? More chance of occurring that that particular word will be suggested. So it is a sheer, or you can say it is a easy to understand. It is a simple probability concept of, but not just probability, we are also applying advanced machine learning and deep learning algorithms to train the machine, because we have to make it and understand that, or it will not understand doesn't mean really it will understand. It's not a human being to understand. So it actually trains on the data, and it will we train the the certain scenario, right? For which scenario, which kind of word can occur. So it's a probabilistic concept. So it's an autocomplete feature is also the same aspect of, right from, because everybody uses this autocomplete feature, because, if you use Google, then you are using autocomplete feature. No need to even use Gmail also, because when you search in Google something in suggestions, you will get and you will click on that, right? So you are using the autocomplete. So instead of you typing it is suggesting and you are clicking on it and you are using the autocomplete feature. So definitely you are using that machine translation. If you are using that autocomplete feature in Google, you are using machine translation, you are using a deep learning model, and you are using AI in your day-to-day life. So that is how you can relate to what you are doing in your real life. So talking about the next important aspect is the healthcare domain. So which is a very important very important place of I can say it's a very important place where we are applying the artificial intelligence. Yesterday I've given some couple of examples of how robots are actually used when it comes to the healthcare domain. So you know in that, building on that particular perspective, we are, to see basically why we are using AI in healthcare. So that is a very common, very simple thing which we have to understand first. So to understand a particular disease based upon data, right? So what happens when we study the symptoms? What happens when we study the scenarios of occurrence of a certain disease? So what happens? It will be easy for us to analyze. It will be easy for us to initiate. It will be easy to us to understand the characteristics, the patterns of the a certain disease, and how that particular disease behaves, right? And what happens if a particular, if a person is having a particular disease, right? So to study this, after studying all these things, what will happen? So what happens if we study all these things? So it makes us to treat that particular, it makes us easy to understand that how to treat a particular how to treat a particular disease. So it makes our job easy, right? This is the ultimate goal of why we are using AI in healthcare. We want to make our life easy, right, in order to treat the particular patient. So yesterday I was telling you an example of a robot actually helping the patient. So if a robot is actually taking care of, right, and it is able to treat that particular person, giving time to time medicine, right, time to time medicine it is giving, and then taking care of the physical exercise and all, what happens? The patient will get cured very easily, right? If a patient is having a sudden issue or something like that, the robot has some training data, or it has been trained, right, with millions of data. So that the machine or the robot is capable of doing something, right? So emergency, something had happened, for example, a doctor is not available. So immediately or on an emergency basis, the doctor is not available. Okay, so this robot, or I can say this particular machine, can do something, right? It can do something, and it can actually help that particular patient to live. So this is how people want to transform healthcare industry, by using AI methods, right? So not every time a particular person can be available all the time, right? So to solve this purpose, we are using AI in a healthcare domain. So there are a lot of advantages also. There might be little disadvantages. We'll come to that and we'll discuss that also. Because see, everything will have a two sides of the coin, right? So wherever there are advantages, there will be disadvantages also. So our job is to minimize the disadvantages and increase the advantages of why we are using AI. So, as far as my personal opinion is concerned, I feel there are a lot of advantages only. I will not say there are no disadvantages, but there are a lot of advantages compared to the healthcare industry, particularly because I'm stressing on healthcare, because we are we are here to learn more about healthcare and the finance domain, which is the banking sector. So that is where we can, we will be talking mostly. So there are a lot of positives in why we can use AI in the healthcare industry. So one more, when I told you some of the things like to understand in drug discovery, understanding by the diagnosis, because a lot of patients' data will be taking who are actually having a particular disease, and based upon certain reports also. See, even we will discover a particular a data set which is an ECG data set where we can understand by that particular person will get a heart disease or not. So we will be doing understanding that by the data set, and we will implement in Python to find out whether the person will actually based on the based on our training and building a model, whether a particular person will get a heart attack or not. So we'll try to understand that by our approach. So these are some of the other things also which I wanted to share with you also, where we have different areas where we are using the deep learning models, like the social media areas also, or the social networking areas also, right? Yeah. So this is very important, as most of us are actually teachers, right? So in helping us to train more and teach more, because first of all we should be a good learner in order to teach well. So always I believe that we are for a lifetime we are all learners only, right? So we learn new things, we understand new things, and then we teach that new things to students. So on that basis, that I think everybody is doing the same thing, right? So we learn and we teach. So that is what we do on a day-to-day basis. So how our learning methods can actually improve, right? How we can uh, improve our skills, and how AI can help us to learn a lot of things, right? So now, you can ask ChatGPT, or you can ask Gemini, you can ask, any assistant to help you to provide, different methodologies, different, outcomes, this thing, that thing. So many things you can take help of the, LLM models in the current day world. So before it was not the case, right? So there are a lot of effective ways of how all these LLM models are nothing but the deep learning models, DL models. So how our our teaching methodology, the way we teach, the way we you know how we interact, how we learn, how we do things on a day-to-day basis. A lot of things have changed in the last particularly I say last 4 or 5 years. How things have effectively changed, and how artificial intelligence, machine learning, and deep learning is actually helping us. So next thing is the black box problem. So black box problem is nothing but this is you can just understand this black box problem by a small sentence, like this is basically relying on the rules to make a decision. So this black box is nothing but it creates a scenario. Best example to understand is like a simulation, right? So we do the simulation, right? Particularly for management students, we create a business scenario, and we try to simulate, right? So simulation is an example of a black box. So we try to create a business scenario. We try to make a decision, right? We create a scenario and we try to make a decision and see how things work out for a particular business. So this is how we actually do things on a black box. Right. So before going into a little more detail, so anybody has any doubts, just want to make sure that you have anything, you can put it in the chat box. You can ask any doubt before we move a little forward. You can just put a and just put a any question. Just give me a minute. Okay. So I think no one has any doubts. Um, I guess. Okay. I think we can go ahead. Okay. Fine. Okay, so we'll continue. So let us understand what is an LSTM. So first of all, what is long short-term memory? So this is a very important concept when it comes to deep learning. So let us understand, in a smaller way of what is exactly an LSTM. So this is basically used for text data. So this is an RNN model. So recurrent neural network is nothing but a model which is used for text data. So why we are calling it as long short-term memory is a particular, a particular word. As we were actually discussing about the autocomplete feature, right? And so I've given an example of Google, or it might be a Gmail. So in an autocomplete, in an autocomplete feature, so here we have to understand that this particular, I was saying some of the words will be trained, right? So there is a probability attached to that particular model. So this probability of words should be in memory, right? And it should be learning that memory, and it should be actually keeping that memory of that particular members for a longer duration of time. So if it has to keep in that memory for longer durations of time, it has to build that particular model in a particular sequence, right? So doing a prediction in a particular sequence of words is basically LSTM. So this much we can understand kind of right now, and and then we can move forward. So what exactly is the role of memory also? So we will speak about memory also in a short thing. So keeping something in memory and helping or using that to make a prediction is what the LSTM model basically does. So it can predict the future of that particular sentence, because when we talk about LSTM, we are talking about text. We are not talking about any images, because for images we have one more called as CNN, convolutionary neural networks. So here we have Okay, so we were discussing about the LSTMs, right? So here, what exactly the LSTM or the LSTM has to suppose actually it should do is this LSTM should build a model in a certain way, and this model has to keep that particular model in the memory, right? So this memory has to help to predict the future. So this is the actual job of an LSTM. So, right. So next is the role of context, and here we can see that while there are certain parameters where you can actually understand the context. For example, if you say that the largest living land animal is an elephant. So I've taken a small example here. So obviously, the when you search this, for example, in a Google or something like that, So it will automatically give you that elephant is the answer for this, because the context is not required in this scenario, right? But here, I grew up in Germany doesn't mean I have to speak German, right? I may be an Italian, or I might be a French, or I might be an Indian, right? I might be a Sri Lankan, or it might be a Thai. So I can be any person. So that is the biggest challenge. What is actually happening when you are you know building a deep learning model actually. So a deep learning model is something where it has to understand the context when it comes to a text. So whether we are using an LSTM, or whether we are actually using whether we are using an LSTM model in a RNN, a recurrent neural network. So we'll just go forward. So this is the LSTM unit. So I'm not going to much discuss on this. So this is basically built on the gates, right? So AND gate, FOR gate, right? So there are different kinds of gates on which these units are being built. So we need not understand much on this LSTM, but the structure of an LSTM cell looks like this, because they are basically each unit which consists of a neural network, which has different kinds of gates. So this much we can remember with this LSTM model. So next is the sentiment analysis of what we can understand about AI. So sentiment analysis is nothing but having a opinion on a piece of text. So for example, this one you can relate to your best example you can relate with the social networking also. So here in the social networking, you have different emojis, different smileys, right? So you can use these different things to understand that how whether it is a positive negative neural. So what exactly this sentiment analysis actually gives you is it wants to know how that particular user is actually feeling about. So how that particular user is actually feeling about how each and every application they want to make things better when it comes to the user experience. So that is in where they try to use the sentiment analysis. For example, applications like the YouTube, right? So YouTube also the same pattern it follows. So you have something called as like, dislike, right? And all those things, and even the comments what you put, uh, in that particular the comments what you put in that particular down that behind particular video are basically that which are analyzed, right? So they will try to analyze that particular comments, how people are reacting, whether it is in a positive sense or whether it is a negative sense, or how people are feeling about that particular video. So the comments, analyzing those comments and understanding the certain behavior of what people think about uh, that particular thing is what the sentiment analysis is actually all about. So next, this is the architecture. So what is basically this LSTMs and this architecture is about is, so there is a concept, we have something called as a probability. So that is what the outcome is about. So I just told you that also. So when you Google, that Google search example, you can relate, or you can think of that Google search example, where you can understand that what is the most probable word that can occur when it comes to the that particular word, right? That will be suggesting. So that is the most that word which has more probability. That is what the outcome is about. So this sigmoid and all what you are saying, that we will discuss again, because sigmoid is nothing but the activation function, and LSTM is something where the thing which keeps in the memory, and then embedding is nothing but which is related to a tokenization. So tokenization is nothing but giving tokens to each words. So on a simple basis, we can remember for time being. Then we'll go a little deeper when we understand the project mode. So tokenize is nothing but giving tokens to each words. For example, for food, one. For awesome, right? So for two, like that, was three. So like that, giving each word, one number or numerical value is what the tokenization is about. So this is what tokenization. So you can just go through embedding and all. Yeah, fine. So we'll try to understand what is the life cycle of a deep learning project. So we'll be discussing a project in a couple of projects as well. So we need to understand that how a particular project actually, how a particular project will be actually running when it comes to a deep learning. So for example, like, starts from planning the project, right? A project planning starts even that before that we have a business problem. So when we have a particular business problem, from there we try to plan this project, and then we try to collect the data, and then we try to label the data. We, in this labeling part and all, we have all the aspects like the we have all the aspects like the data cleaning, data preparation, right? So all these things comes into the data normalization, and all those things actually comes into the picture. And then we have or we try to create the label by using the unsupervised methods, and then we build the model by using the supervised methods, right? So whether it might be a machine learning model, whether it might be a deep learning model. So initially, right, it has to start with the business problem, correct? No. So once it starts with the business problem, then we can move forward, and then we can go with the data collection process, and then labeling it by using different supervised, unsupervised methods and all. Then build a model, whether it might be a supervised machine learning model or a deep learning model, and then that model has to be tested, right? Evaluated, and then it has to be deployed into the real world, and then it has to be monitored as well, whether the whether the project is working correctly or not. So next is the project planning. So here we can actually, this is what exactly we have also discussed also. So right from the goal setting to the choosing the metric and everything, setting up whether, we are mostly discussing about deep learning. So we will apply the deep learning models using TensorFlow, right? Keras and TensorFlow. We have different methods like the, PyTorch and all those things also. Yeah. So this is, this is how things actually work out in the real-time scenario. So the most important questions which has to be asked also as well. So any good published work on similar problems, right? So that is what we focus more when it comes to research as well, right? So when we are in a research-oriented field as well, right? Particularly when we are in the teaching field, we focus more on the research problem as well, right? So we try to focus more on the research area, and we try to ask these questions when we try to understand, right, the certain scenarios. Like for example, in the first question I was talking about. So any good published work, and then we have our resource available for training and deployment. And then, when it comes to how costly are the wrong predictions. So how frequently does the system need to be right to be useful? And then we can understand how, data availability, how hard is to acquire data. So, we have different methods, we have people to analyze, but, the most important concept is to acquire the data. So, the most difficult part is not to acquire data. Acquiring quality data is very important, because even when we have data cleaning methods or any kind of method. So even though we have different kinds of methods, the most important aspect is how good we are able to employ these methods in getting our data cleaned, or in data being more useful. So how good we are able to do it, that is what plays a very important very important aspect as well. So because the next question was that only, so how expensive is the data labeling, how much data will we need? So that is a very tough question to answer, because how much, because many of you would have done, research publications, know a lot of things, right? So, getting the right amount of data. So it's not just for doing some research work or, just doing some, it's not just that. So to, even for model building also, it is very important to get the right amount of data, and that too, one typical part in, I can say, when it comes to deep learning particularly, the one typical part in deep learning also is that you need a lot of data, right? It's not like a machine learning model. In deep learning, we actually need a lot of data to build a model. That is why it is very difficult. Hardly, that is why if you are having huge amount of data and you have a good quality data, then only people actually go into building a deep learning model, because deep learning models cannot be, it can be built, but huge amounts of data give actually good results when you are building a deep learning model. So always data is a very important aspect, whether you are building a deep learning model for AI or whether you are doing a research. So anything, data is a very important thing, which it is very important. We are living in the generation of data, I can say. So we are, living with the data, right? So it is very important, and we are creating or generating more amount of data as well. So how effectively we are using the data, how well we are organizing things, and how well we are doing things is what eventually what matters. That is extremely crucial when we talk about machine learning models or a deep learning model or a basic statistical model. Always data plays a very important role. So this is what we have actually discussed. I'll just move forward on this. So deployment and all. Now we'll go on the direct focus on a deep learning model. So deep learning model is basically based upon the neural networks, artificial neural networks. So when we speak about the word neural networks, we are talking about the word neurons, right? We are talking about the word neurons. So neurons are nothing but the cells in our human brain. So what does this neuron actually do? This neuron actually triggers our instincts in the brain, right? So everybody would have studied science, right? In your school days. So everybody knows what is a neuron. So why I'm speaking about neuron is our deep learning technology is actually based upon neural networks. So how a neuron actually triggers something in our brain, right? So how it triggers, the same way a neural network is actually built on that same feature, or I can say same mechanism or methodology. So how things work in the neurons, the same way the neural networks are actually built upon. So you can see that how an artificial neuron has been built using the so artificial neural network has been built using the real neuron. So biological neuron and an artificial neuron. Okay. So when this neuron was actually found is in the year 1943. So it is in the year 1943 where the researchers Warren McCulloch and Walter Pitts is what they thought of something, how brain, because see, always understand that what is what we discussed yesterday also, when we discussed that what is an artificial intelligence, right? So I told you also that mimicking the human behavior is what AI is. So now the word mimicking the human behavior is what AI, and here using a biological neuron to create an artificial neuron, so both will be in sync now. So these two people have got an idea where why don't we use the neural technology of building an artificial neuron. So this neuron is based upon simple logic. Somebody else did said. That I don't know. I think somebody will post in the sorry. So this attendance part, I'm not sure. Can just wait. I think you will get the link for giving the attendance, and just wait for a few minutes. Sorry. Okay, so on that basis, a neural network is actually built upon, where the using a simple logic gates, or I can say a simple gates or a simple logic. I can say simple logic is a simple word to tell to describe a neuron. So this is a basic definition of a neuron. So neuron is, it takes on the a biological neuron, and it basically adds some weights, and it sums up and it transfers the function. So it is basically a nonlinear output. Okay, so this is the distinguish feature between the biological neurons and the artificial neurons for your reference. So what is we are calling as a cell nucleus? We are calling it as a node, and what we are calling it as dendrites, we are calling it as input. Okay, so when you see the word cell nucleus, dendrite, synapse, and axon, we remember our school days of what we studied science. We would have we drew the neurons and all those. No, so yeah, it is the same thing. So there are input and there is an output. So in this between, there is a lot of things called as adding up the weights, applying the activation functions, right? So like that, we have different kinds of things. What happen when it comes to the artificial neuron? So next thing is the neural network. We are calling the neural network as a perceptron. So this is a perfect example of how to understand a neural network. So here we can see that there are inputs and there is an output. So this is what exactly we actually expect. Now what is happening in the artificial neuron is there are weights. So weights are nothing but the importance to each input variable. So in a simple terms, you can remember like this: weights are nothing but the importance or the characteristics or the features of that particular input variable. So that is what the weights is about. So adding the weights, because some weights will be positive, some will be negative, some will be different ways. Those particular weights are there. So adding all those weights, inputting them, and applying the activation function, then you can get your output value. So activation function is nothing but a mathematical and a statistical function. So yeah, this is what we were actually discussing. So there is an input and there are weights added to it, and then we have the summation function, and then we have the activation function, which is the applying a certain mathematical or a statistical function, and then the output. So yeah, it's the same thing. So activation functions are of different types. So when we are implementing the project also, we will come across different activation functions like the sigmoid function, ReLU, right? Different kinds of activation functions will come up. We have tan-h function. So like that, we have multiple activation functions which we will apply. Okay, so just skip this. Yeah. So a few I've actually mentioned. So we will not go much into mathematical formulation and all, but you can just remember that there are certain functions. So these functions are nothing but the functions which can be applied or which can be actually used in a certain way, where that particular model can be applied by applying those weights and all, and how you can expect the output. So that is how these activation functions are used, and based upon the scenarios and based upon the situations of which activation function has to be used in which scenario, we are actually going to use the activation function. So we have some of them I've mentioned here, like the sigmoid function, tan-h function, right? So, and we have ReLU. ReLU is nothing but rectified linear unit. We have more like leaky ReLU, right? So we have many functions which are actually there. So only a few I've mentioned. So we already have discussed what is a deep learning network. So deep learning model has more layers in it. That is why the word deep is actually mentioned in the neural networks. That means the layers are deep enough, right? There are a lot of deep layers when it comes to the deep learning models. Okay. So overfitting, underfitting, we'll just discuss this later. So maybe you can take a 5 minutes break. Just give me 5 minutes. We'll continue with the session. So we'll continue. Just share my screen. Okay. So let's continue. Okay. So let us understand. We were actually just discussing about the neural networks, how things work in a neural networks, right? So how a basic example of things work in neural networks, and what happens when it how a neural network is actually built upon, right? So this is what we were actually discussing about. So now coming to the part of how the neural networks actually work. So there are certain parameters where how a neural network actually works, right? So there are certain things, right, we need to understand before going into a project. So I'm just discussing some of the aspects as well. So one of the very important problem is the overfitting problem, right? So this overfitting problem actually comes in both training data, sorry, in machine learning as well as the deep learning. So it might be either in machine learning as well as in deep learning. So in both areas, you can uh, get this problem of overfitting. For example, now let us understand that what is overfitting and underfitting. So first of all, to understand what is an overfitting and underfitting, there are certain parameters. So overfitting is nothing but the training validation fits well and testing data doesn't work well. So here there are certain things when we try to understand the training data and the validation data. So let us understand in a very simple manner. So there are two things when it comes to the data. So one is the training data before we build a model. One is the training data and one is the testing data. So testing data, we are calling it as a validation data set or validation data. So testing and training and testing. Now, what happens usually is we train a model, right? So we train a model, we build a model. So that particular machine learning model or a machine learning or a deep learning, anything, right? You can imagine anything, not a problem. So this model will perform well inside the training data. So it will perform well in the training data. Maybe we get a good accuracy of 85, 95, 93%. So we get a very good accuracy when it comes to the training data. And when it comes to the testing data, it fails, right? So, or, it underperforms in the testing data. So this is an overfitting problem. So easy to understand what is overfitting is that it performs well in the training data and doesn't work well in the testing data. That is what an overfitting is. So in underfitting we have something where it doesn't perform well in the training data as well, and it also doesn't perform well in the testing data. So either way it doesn't perform, it is an underfitting problem. So it fits well in the training data and doesn't work well in the testing data is what the so to understand this one small example I can take. Maybe in healthcare domain only we can take one example. For example, like you have taken a data set, right? Let us take our data set only, our ECG. So, I will explain the parameters in the data set and we will discuss. But, to understand what is this overfitting and underfitting in machine learning and deep learning, we can take one small example where, we have a certain variables. We try to train the data and our model has built, or our model has performed well and it has built a model. So now in our data set, what I'm going to discuss, my model has to predict based upon the data and unseen data that the model has to predict whether that particular person will get the heart disease or not based on the data provided. So if I have to use that particular model and I have to test whether that particular person will actually get the heart attack or not based upon the data which is provided where the model has been built up. Now, if I'm testing it, I'm applying it on unseen data or maybe a testing data also, it is not able to perform well. So that becomes an overfitting problem. See, why this overfitting occurs is there is a very small reason to understand. So instead of capturing the important elements in the, or you can say important parameters in the data, or when it comes to our data set, we can understand that which are the most important parameters which contribute directly to a person getting a heart attack. So if a person has to get a heart attack, they have to be certain parameters. So that important parameters, that only we call is as a features, right? So we do feature engineering. That is why when it comes to machine learning or a deep learning model. So that important parameters which are directly contributing to the outcome variable. Here our outcome is the person getting a heart attack or not. So our model has to capture the important elements in what are the important elements that whether that particular person or whether that particular model is able to capture all the important things or not. So it should not capture any noise. So noise are nothing but anomalies, or you can say outliers in the data set. So it should not capture, a very simple way to understand is our model has to capture the important parameters or important variables, features or characteristics of the behavior. So it has to only capture the important things to build a model. Instead of that, it also captures unnecessary things. So if it also captures unnecessary things, what will happen? The model will perform, it may perform well in the training data, but when it comes to the actual data, when you actually want to test it on a validation data set or you want to test it on an unseen data set, the model doesn't perform well. So this is a huge problem when you are building a model. So that is why it is very important to do the feature engineering or the feature selection and to perform you based on that and then to build the model. So this is a very important perspective to understand how you can build a model. So how to deal with overfitting? Right now, I'm just skipping this. We'll come back to this again when we actually are discussing the project. Okay, so it will be easy to understand. So by taking one small example, I've explained you what is this overfitting and underfitting, and what happens when it comes to the realistic data set. So okay, so this is the example of I've taken. So right, by this understanding, you might understand a little by this example that okay, so things will work like this. So we'll come to this L1 regularization, L2. There are two kinds of regularizations. There is a dropout also. So dropout is not, L1, L2 is lasso and ridge regression regularization. So we'll speak about this later. Okay, I'll just skip this dropout also. Yeah. So before things which are important for our project is one of the important things is the loss function. So loss function is nothing but a difference between the predicted value and the actual value, or you can say the outcome value and the actual value. So the difference between the actual value and the outcome variable is nothing but called as the loss function. So actually here we want to hit the 10, right? But we have hit the 8. So, the actual loss is 2, right? Because actual minus the predicted value. So whatever value, for example, we predicted a particular, for example, this particular loss function can be calculated in different ways for different things. For example, for classification, the loss function is different, and for the regression problems, the loss function is different. So how things actually turn out when it comes to the classification and regression is somewhat different in both the things. So let us understand how it works. I just now was telling you about this. So how it works, one is the regression loss and one is the classification loss. So regression loss, we use two different methods. One is the mean squared error and the mean absolute error. Okay. So classification loss, we have a couple of things. This is the cross entropy and the hinge loss. Right. So now let us go one step further, very close to our understanding of a project. So is that a TensorFlow? So, yesterday I was actually mentioning about the Google's Tensors chips, what they're using in their, smartphones. So on the same technology where the Google's brain team has developed a tensor chip. So a tensor is nothing but a multi-dimensional array. So tensor is nothing but an array. Flow indicates the flow of events, or I can say flow of the operations. We say graph of operations, but you can remember like a flow of events or operations, what happens on that multi-dimensional array. So that is why his chips he named as tensor chips, but the process of what happens in a deep learning is nothing but the tensor flow, because it's a flow of operations. So next is the what is a TensorFlow? So as I've told you, it was actually developed by a Google brain team in the year 2050, and this is a very, very important library which is basically used for deep learning tasks. And even we will use this TensorFlow to understand that what happens, in this TensorFlow. So yeah, I can skip this. Yeah, so it's basically the library, or the module, which I can say it's a library actually. So the library which is actually used by us, or we will be using in the upcoming project. We'll use the library TensorFlow Learn. So in this TensorFlow, this is basically a high-level API or an application which is used for more computational power and more deep learning tasks. So there are a lot of modules and functions which are inside this TensorFlow. Yeah, so these are some of the advantages. And yeah, one important thing which we have to remember when it comes to a TensorFlow is nothing but the implementation using the GPU. So yesterday, I was indicating this also when we were speaking about the NVIDIA graphic card company, right? So it is, those are all GPUs which process flow. So TensorFlow uses your laptops or a desktop, right? It uses the graphical processing unit inside your whatever you're using. Either you're using a GPU in a smartphone, whether you're using in a tablet, whether you're using in a laptop or a personal computer or a desktop, anything, right? So for compilation, the TensorFlow actually uses your GPU more than your CPU. For a simple task, it will use the CPU, but for more computational, like running the cycles, epochs, it mostly uses the GPU in the computers. So yeah, so visualization is one of the aspects also where we try to visualize. So we will also try to visualize in our project also. So why we use this visualization is basically to understand how the data is actually underfitting or overfitting, or how the loss function is turning up. All those metrics we can actually do by using the visualization techniques for the TensorFlow. So this is how the graphs actually look when we plot them. So we will do as well. All right. So next is the Keras. So Keras is also a high level API, which is actually, it's a framework, to be fair, which supports TensorFlow. So this also the same, uses more of GPU, the graphical processing unit, and it also uses the CPU as well to compile the deep learning tasks. Yeah. So why I was actually, I can say why I'm stressing that CPU GPU thing, because for running a simple machine learning tasks, a normal processing power is sufficient. But to run a deep learning task, because deep learning word itself has a lot of deep in it, right? So it needs more computation power, and it needs more uh, you know skill to run that particular more power to run that particular task. So that is where the GPU creeps in. So basically, this Keras uses the TensorFlows, Theano, MXNet, CNTK, right? So all these particular things as a backend. So you can remember like this, like Keras is nothing but a framework which uses or which runs on these different kinds of things. So TensorFlow, mostly I'll be using TensorFlow. Okay. So TensorFlow, why? Because it is actually developed by Google. And in the current market, even CNTK is being used much. I've seen some of the projects which are done with CNTK, but mostly people are using TensorFlow. So why use Keras? Because it is a deep learning technology. So already we have discussed this. So yeah, we do optimize. So optimization techniques we will come up, and I will not take much time to explain this optimization techniques, because uh, you know without conceptual understanding, it is very difficult to understand these optimizers. But I will tell us on a smaller aspect of what are these optimizers. So optimizers are nothing but which optimize the solution. So why these optimizers are basically used is, these optimizers actually, what will happen is, when a model has been built using the tasks, or tasks, or using the activation functions, weights, and all those things, we build a model, right? So once we build that particular model, we want to optimize that particular solution. That means we want to get the best solution possible for when we are building a model. So how we talk about optimizer? So the best possible way it will actually build a model. So what happens if it builds an excellent model? So it can predict well for the future, right? It can do well also on the unseen data also. So in this way, the optimizers help us. So in all these optimizers, because the most used optimizer is Adam. Okay, so adaptive momentum estimation is the optimizer, which is, it is at the last. So Adam is even I remember using most of my projects. I use mostly I use the Adam optimizer only, because Adam is a very what happened in the real time with GD is the gradient descent, stochastic gradient descent, and then we have the stochastic gradient descent with knee badge, stochastic gradient descent with momentum. Then we have the NAG, then we have the ADA-grad. So what happened when it came to Adam basically is, the person who has designed Adam, adaptive momentum estimation, has rectified the flaws whatever are there in the GD, which is the gradient descent, stochastic gradient descent, and all. And he mixed all the optimizers. He used all the technology of the optimizers, and he has built it into a you know an optimizer, which is basically called as Adam. So that is why when you see a deep learning model, mostly the optimizer which is actually used is the Adam. Okay. So yeah. So gradient. Yes, please. Somebody has raised. Yes, I was actually about to stop. So thank you for raising the hand. Yes, please. You can type your query or what you want to ask in the chat, so that I can answer your question. Actually, I'll give 5 minutes to ask questions. Yeah, I think I've stopped at the correct place. Yeah. Yes, please. So those who have doubts, you can ask me. Then we'll move. Then we will move a little forward. Because all these optimizers, everything what we are discussing now, TensorFlow, Keras, everything we will apply, because all these things, loss of power could cause. What is this? And loss of power? I couldn't understand your question. Attendance. Come on, Ed. Sir, do you think mistakes done by a robot cannot make the patient suffer? Yes, that is why when actually I've discussed, when I told also, I was telling one thing, right? There were two sides of the coin. So definitely there are a lot of disadvantages, but I feel the advantages are more than the disadvantages. So yeah, yes. I hope I have answered your question. Chandana, okay. So Chandana can share attendance to Ashish when time is right. Ashish, yes. So any other questions? I'm ready to take any questions.
Shashank, I have sent you one question so that I got from my YouTube. You can answer that question. Like before you explain, no, same question, but I added some sentence.
Okay. Sir, do you think mistakes done by a robot cannot make the patient suffer, and loss of power could cause a serious problem? Are there any remedies? So Chandana, for this, the most important thing is, every machine or a robot, because when we were discussing about a healthcare, and we were discussing mostly this FDP is on healthcare. So discussing about this certain scenario, when we are using a robot for treating patients, so I would not recommend a robot to do operations and all, right? So that I'm pretty much against, actually, to be fair. That a human being can do, but taking care of patients, helping the patients, doing certain things where a human being cannot do it all the time, that's in where the robots can be used. And coming to your question, in that particular scenario where that the loss of power, so that can cause an issue. But there is one, I hope I can answer that question in that way. There is a certain scenarios for a robot where it should not break that particular barrier. So there are certain laws on which the robots are actually built. So so that particular uh, loss, but the robot should not actually break. So it should not think on its own, and it should not act on its own. So actually that will not happen, because when a person is actually building a robot, the loss of robot will be followed. So to be fair, maybe this question we can think of, in many science fiction movies we have seen, robot has its own mind, and it can think, and it tries to destroy human beings, and that's why we are calling it as science fiction, because there is a lot of fiction involved in that particular movies what they are taking. There is a negative impact of that movies also. I'll tell you, because people will be afraid because of that only. People keep on asking that using AI, particularly in robots, maybe it can cause some serious issue to our human life and all. But in reality, that will not happen. That is just a movie. In reality, uh, I can 99.99% I can guarantee, because a robot cannot uh, break those laws on what it is actually supposed to do, and it cannot do that. So any remedies for that is to take care, because for example, let us keep AI for a side, and let us take our human brain, because I was discussing about deep learning. We were talking about the neural networks, right? So neural networks are actually based upon the neurons, right? So our brain, how our neurons work, the same way they have built the neural networks. Okay, fine. So that is okay, understood. But when we are saying that it is based upon our behavior or our neuron, so for example, when we do a certain mistake in our life, right? So we try not to repeat that mistake. Why we will not, if we know that it is a mistake and we try not to repeat it, why we think like this? Because we think that it is not good for us, right? So it is not good for us, and we don't want to repeat that particular mistake, because it is not just good for us. That is not only the reason. We also will not do that mistake. We try not to do, because that particular, every action will have a consequence, right? So we may have consequences for doing that particular mistake. So that consequence might be in a smaller way, might be in a huge way. It may destroy our life also. It may, it may not even cause even a small problem. So the level of destruction may vary, but it will create some difficulty in our life. That will happen. That is why you're calling it as a mistake. So it doesn't create any difficulty. We are not calling it as a mistake. So since a particular, I'm discussing about a small problem which we get in our, which we done as a mistake, and it is creating some certain issues. So we think that we should not do it again, because it is creating some problems, and every action has a reaction. So everybody knows this sentence. So now think in this perspective of a human being thinks in this way, correct? So now think that, when a person is actually building a robot, do you think a human being will build a robot in such a way that it actually destroys human life? No, that will not happen. So this is a logical statement. Once I had a debate also on this, so I remember. So with a student in a college, one he was telling, "But how can you tell that?" Obviously that is a logic. That is where we call it as a logic. Because human being will not do that. It doesn't create a problem or a threat to mankind. So that, I think, there is, the problem first of all will not be created. If it is created, a human being also has the ability to handle. So that is why I'm saying that it is very important uh, for a human being to use the technology optimally also. So whether it comes to any AI technology, because there is a lot of limitless opportunities what a mankind can do. But it is our conscious, right? So that is where always we can say that human being is a far superior person, when it, how much of technology, even though it comes, because our thinking ability, a machine will not have, right? So we are, why we are building AI machine, right? So logically, any one of you can think on your own, right? Why we are building this? To make our life easier, not to destroy human life, right? So it is just to make our, you can think of a simple example now. These AI vacuum cleaners have come up, right? So they are, why they are used? right? So they are used to cleaning the house, right? Because nowadays now people are very busy, doing things, right? Working, doing business, all those things. So people are very busy, so they don't have time to clean the house or all those things. So based on that example, we are using AI vacuum cleaners. So many of you already would have bought it. So maybe some 20,000, 25,000. You are seeing AI vacuum cleaners in the current, uh, market, where it actually cleans the house, right? So things are moving forward in such a way. Uh, they just want to see why things are, I can say how things, the way things are actually being developed. The only agenda is to make our lives better, right? So I will not agree with AI if our life is not getting better. Technology is improving, but human life is not getting better. I will not agree with this 100%. See, if a particular AI technology has been built, it should make human life better. That is the first point. That's it. There is no debate on this. So our life should become better. Then only the technology is useful. If it is not, making our life better, then the technology is not good. So that is up to us to decide whether we have to use it or not. So this is how human brain is capable of thinking, where a machine cannot think on this. So yeah, so that is the way actually we have to think, and we have to move on. In that, because life goes on, with different aspects as well. So AI is one of the integral parts. So yesterday also I was telling about this. So AI will transform our lives. The AI will not destroy our lives. It will transform. Sorry, it will transform the way we work, the way we used to do things, right? That transformation will happen, right? But it will not destroy. So a transformation. So a simple example like these optimizers only. So before, the first optimizer was gradient descent, right? So when people have found gradient descent, everybody's used gradient descent because there is no optimizer. So whether it is giving best results, not giving best results. After that, stochastic gradient descent came. Then we have mini batch, then momentum. So one by one. So what happened? Little advancements have come in the optimizers. People started using the best optimizer for that particular, for getting that particular outcome. Correct? No. So in that same way, right? So we have transformed from gradient descent to the stochastic gradient descent. Then after that, we have transformed to stochastic gradient descent with min batch, and so on. So now we are in the Adam optimizer. So I was telling you, I use all for all my projects. I use the Adam optimizer. Correct? No. So maybe in the future, maybe after 1 year or 2 years or 6 months, I may not use Adam optimizer. I may use some some other optimizer because the technology will actually grow, right? So now the best optimizer, compared to this Adagrad, NAG, RMS prop, everything, stochastic, gradient descent, everything compared to all these is Adam is good. Maybe in 1 year time, maybe if I take again, I'm taking this kind of AI class, maybe some other optimizer comes. So and that is a good optimizer. So I have to change my approach also, stating that this kind of optimizer is good, right? So things change. So this is what transformation is about. So transformation is nothing but transforming from one thing to the other based on the requirement and based on the scenario. So this is how things work. So gradient descent, these things I just keep it for later. Okay, I just put this in my slide to make you to understand. This is all on the gradient descent. So these are mostly on formulations. Okay, so we don't need to understand formulations and all here. Okay, yeah. So yeah, so yes, which is related to our project. We'll try to understand more. Okay, so optimizer, you can you can think of Adam being used much. Okay, adaptive momentum, estimation. So now, next is the data preprocessing. So this is one of the very key important things when it comes to when we are doing a project. Okay, so whether it might be any domain, the most important thing is the data pre-processing. So data pre-processing is nothing but standardizing and normalizing. So what is this standardization and normalization is basically the same. Okay. So what happens in this? So a simple thing to understand is this is actually related to statistics part. So for example, here you can see one small formula. Okay, I don't want to go in formulas, but here to understand standardization, it's very important to understand a very small formula, which is the x minus m by sigma. So this z or z is nothing but the standard normal variate. Okay, so this is related to the normal distribution in continuous probability distributions. So this is a concept in statistics under continuous probability distributions. In that we have normal distribution. That is why they call it as normalization, because that means applying the normal distribution. And we have one formula which is z is equal to or z is equal to x minus m by sigma. So here, some places if you see this x minus x bar, so you will see capital X indicates the data points, or you can see that it is mu minus sigma also, right? So now here you can, so basically it is difference between the data points and the mean value, okay? Divided by the standard deviation. So when you do this, the values are between, okay. Okay. So now the values actually come between the range of 0 to 1. So once the values, and if you're applying the standardization points, the z value actually lies between -3 to +3. Okay, that only we call as a 3 sigma limits and 3 sigma limits, which are the 6 sigma limits of the normal distribution. Okay, so we'll not dig deeper much. We are not discussing the statistics class. So we will not go much, but you can remember in this way that the standardization process is basically nothing but applying the normal distribution and deriving a standard normal variate, which actually the z values ranges between -3 to +3. And now talking about the normalization part. So normalization, it is basically making the values between 0 and 1. So it is very important to pre-process the data. So if we pre-process the data will lie at one place, right? One cluster, and you can easily identify the outliers or anomalies in the data. So outliers are basically the observations in the data which are not supposed to be in the data. So those are outliers, and the anomalies are nothing but completely odd observations which are completely there to disturb the data points and build our model. So anomalies are very like an odd man out, right? Which are completely absurd and which are completely out of our business. So that kind of things are called as the anomalies. So batch normalization, so is the same thing only. I'll just skip this. So why we actually talk about batch normalization is it is we say normalization in machine learning and we say batch normalization. So it's the same thing only, but here we have a lot of neurons because we are using the neural networks, and our training data is also more. So we actually try to do the batch normalization part. Okay. Yeah. So gradient also, I'll just skip this for time being. I'll come back to this. Yeah. Skip this. Parameters and hyperparameters, I'll explain. I just want to finish what is very important right now. Reputability. So now I'll skip. Let's come back to these things when we're discussing the project. So it will be easy for us. Okay. Yeah. Because some of the things, no, just discussing the theory will not be that much of use. So once we are into the project, it will be easy for us. I'll come back into certain places of how this is actually related to us. So that way we will discuss. Okay, fine. So now next thing is AI in the healthcare industry. Uh, ma'am, Chandra, ma'am, can you just see the day one attendance also? Some one person has messaged me. Uh, Chandra, ma'am, I think you can just see this. Somebody was asking about attendance.
Yes, I will share in the chat.
Yeah, yeah, yeah. Then asking whether how we can see the attendance part also. So you can just take care of that. Not just day two, day one. They're asking. I don't know. I think we cannot share the day one part. I guess, right?
Yeah. Day one we are not going to share. That I will tell them later, like last 5 minutes. Okay, I'll take it up so that time
Sure,
I will
sure,
inform them.
sure, sure. Thank you. Okay. Okay. So, um,
Prashant, your voice is breaking.
certain areas of how things are working in healthcare, particularly uh, how they are actually
Shashank, am I audible?
revolutionizing the healthcare industry. There, you know, and how things. That's how words are actually being used. Is my voice audible now, Chandra?
Yes, yes. It is.
Okay. And suddenly I got disconnected. Okay. Yeah. Okay. Fine. So we were discussing about how AI is actually revolutionizing the healthcare industry of how it can treat patients and all those things. So yeah. So these are some of the examples of how it is actually or how we are using. So one such example is a medical diagnosis, right? So all these AI powered tools, what we are actually using, they are basically used to detect the diseases. That's how it is extremely useful that what we are doing using deep learning is extremely helpful in it. So this aspect of how that particular AI tools, for example, like using the X-rays, MRI scans, what we will be discussing is also an ECG data. So where the how using the data set, whether we can predict whether that particular person will get a heart attack or not. So we can understand that by using a certain kind of data, by the scan images or collection of data, whether that particular disease can occur. So, for example, by using X-rays, we can detect the different images. We can detect whether that particular person has a tumor or a anything, any kind of disease. So that is where the in the medical diagnosis approach or a medical area where AI is actually powering the things and useful in that particular scenario. So next is the personalized medicine, where in different industries of using treatment, creating drug discoveries, right? So building different kinds of simulation tasks using because even the drug discovery is extremely important. Developing different kinds of drugs for different kinds of diseases. So it is a very important aspect when it comes to building the medicine. So, and these are some of the aspects of what happens in the healthcare sector. So, taking care of the patients and giving an accurate information, and using robotic technology or using medicines or using this AI. So it actually helps in reducing the cost as well, helping in the diagnosis, and I just mentioned about the drug discovery as well. So next thing is the assisting the patients, right, or taking care of the patients. So this we already have discussed on this. So not just having a robot in a hospital which can help you, it is also having a chatbots and a virtual assistants. So that is also extremely. So please can share contact details. Okay. Okay. You know, share. Not share actually. Yeah, in healthcare. Okay, good. Sure, sure. I would really like to help you. Um, um, let me- right. So now coming to the surgical assistants. So this one, I'm not a huge fan of maybe assistance is fine. So that is why I took the key point of mentioning assistance rather than doing a direct, a full surgical thing by a robot, right? So assistance is fine. It can be accepted, but not a full surgery as of now, as far as my opinion goes, or how people think is also. Then next is the automating the routine tasks. So automation has always been a part of our way of how we are doing things, because maybe last few years automation is extremely important, because without automation it is very difficult. So it might be any sector. So here we are talking about banking and healthcare, but not just this sector. So anywhere automation has become a very important and an integration or an integral part of how things are actually working. So drug discovery we have already have spoken about, and then we can also talk about the healthcare industry. So in the healthcare, sorry, in the mental health also, we are using several. I think I can tell you this example of people using smartwatches, right? So in smartwatch, when you go for a walk or you go for a run, what we do actually, we try to monitor our a sugar level or a blood pressure, our heartbeat, right, heart rate and all. So why we monitor? Because to understand our certain things, that is how data is actually produced. So based on what exactly happens, the data which is being collected, based on that we can decide. That is how these models, deep learning models, actually help us. So so in understanding whether our particular our particular data, right, how what chances, what are the chances that we might encounter of having that particular disease. So that is how, or that is the power of data, which we can, that is the power of deep learning and AI, where we can, try to understand by the models what we have built, taking from the data. So, when you use anything, for example, like a Google Fit, not just the smartwatch, even Google Fit produces data, right? How many steps you have worked, what is your heart rate, right? So everything, it can also detect. So what happens with this? You can, it can, they will use that data for analyzing to build a model. So that is how we can come across certain things that, okay, so this is how, so these, for example, if you are having a certain symptoms of a heart attack, doesn't mean you're having a heart attack, right? So that means there is a relationship between the way things are working out for you and the risk of having a heart attack. So, this will create an awareness for us to understand, that, okay, so let me be very careful in how things actually I'm doing, right? So this is extremely useful. This technology is extremely useful, so we can be assured that we can predict that having these kinds of symptoms can actually lead to a heart attack. So in that way we can be very careful, and we can be very cautious in how we do the things. So yeah, COVID-19 was one of the examples of, it was it's an outbreak actually. It's not an epidemic. Sorry, it's an epidemic outbreak. So it's not a disease where we can predict, we can plan, we can, it is like a complete outbreak. It was a disaster, I can say. So yeah, so even in NLP records and all, we are using, and then we are in the mental health, wellness coaching to predict, using the algorithms. So even nutritional recommendations also, because now, nowadays I see people using their nutritionists also to have a certain lifestyle. So how how they can build their particular life, and how they can actually uh, you know live in certain way that they will be away from diseases. So even in health, wealth, you know, health and wellness, right? So there's a saying, right? Health is wealth. So even in our you know health, we can by using this AI technologies of even creating health goals, taking you know a very good diet, right? So these algorithms track the way it will help you what you're having and what you can do based on that, and then you can plan it accordingly. So this is how things are actually working out in the real time scenario and all. So virtual assistants, so many applications, many hospitals or many people nowadays you can actually get that 24/7 assistance as well. So you have the chatbots, or you can say virtual assistants, which help you to if you are having a certain kind of problem, they will try to generate that solution. For example, that solution doesn't work out. Maybe you can come up with maybe you can it is very important that this kind of solution is not effective, and you may have to take a little advanced treatment. You're not actually not that great, so your situation is not that great. So this is how you can analyze, and you can take things. So A and finance and all, when we discuss the project, we'll discuss. So tomorrow, what we'll do is we'll straight away go into the project, because some of the things what I wanted to tell I have finished. Something which is related to a project I've almost covered, but there are some more things also which I wanted to discuss. That we will discuss when we are discussing the project. Maybe we can come back to the PPT once or twice based on the requirement, or there itself in the project I can explain. So we'll take the code and we'll explain. So I will explain, and then we can try to understand using the data set how to how to run the code, and how to understand what happens in the code, what is the logic in it, and how things work, how to build a model, how to test the model, and all those things we will see in the I think Monday. Yes, we have a session on Monday, so we'll see that in the Monday session, and we'll try to understand. So if you have any questions, you can ask me. So you can ask. Yeah, sure. I'll share it with the. Uh, I'll share it so that you can uh, just go through, and maybe if you have anything also, you can ask me. Sure. Yeah. So Chandana, I'm done from my side. So anything else you want to tell to? Uh,
Yeah, okay. I'll take that note. Thank you, Sushant. So, dear faculty members, I hope everyone done with your attendance. If not, I'm sharing it. Please mark your attendance, and any more questions you can ask me. Like day one attendance, we can't able to share, and 60% attendance is mandatory for the certificate. So no need to worry about that. If you missed out for one day, it don't affect on your certificate. But make sure from today onwards you are marking your attendance. At least 3 days attendance is required. And tomorrow, on day after tomorrow, we don't have a session. So from Monday, again we can resume this program. Yeah, I don't see any questions in this YouTube and Zoom as well. So good to go. Yes, Jamil sir, we'll post that. So yeah, we'll wind up the session and we'll meet on tomorrow. Sorry, on Monday. Thank you.